Hello, dear students. Once again inviting you to this series of mathematics problems. Today I'll be teaching you logarithms, and the first part which I'm going to deal with is standard form. So today I will start with standard form, which is a basic part of logarithms. Now today I'll teach you uh, standard notation. Standard notation, or sometimes somebody might call it standard form. So it can be standard form or standard notation, so it's the same thing. Now this standard form or standard notation is always written in this way: a times 10 power n. So this is the standard notation which I'm talking about, where n any is an integer. It's an integer. N is an integer. Okay. N is an integer, and the a is a decimal number. So it's a decimal number. So always a is a decimal number. For example, just consider this one. For example, 2.92 times 10 power n, which maybe is equal to 2. Okay, so this one is a, and this one is 10 power, this one is n. Okay, or this one 3.526 times 10 power negative 3. So this is the standard form. So we are now going to drive our mathematics form to the standard notation, as I'm going to show you. So look here, you can be given this. It's not the first example, but it's just the first explanation on standard notation. Now you can have this one, maybe 290, and you can be given a question now to write this one into standard notation. Standard notation. Okay, then proceed. What you have to do here, I'm giving you now the simplest way of writing the standard notation of this number. Yeah. Now think of two imaginations. Just think of that you have a first player. You have the first player. Assume you have a first player. Okay, and you have a second player. Just think of this scenario. Okay, now always the first player is the first number from the left hand side. This one is the first number, first number from left hand side, and the second player is the second number from left hand side. Now from this case of my number here, now the first player is 2. The first number from the left hand side is 2, and the second player is 9. The second number after the first, called the second number from left, so it is 9. Okay, now the first step of writing the number in standard notation, you need to identify the first player and the second player. Okay, now as you know, the one of the characteristics of players, especially for example if it's a football player, they always move around the playing ground. Okay, so these numbers or these players will also be moving, but the first step now is to identify the first player and the second player. Now the Another step is now put after identifying, now put the dot sign or point or sign between first player and second player. Okay, and second player. Okay, it's very important. Now put the dot sign, okay, between this first player and the second player. Now for this case, 299. Now between, it's here. Now this another step is add then 10 power what? We don't know. Now it's 10 power any. Now n is now count the numbers, the number of items from the dot. Now for this case, I have first number, second number. So I have 2 items from the dot sign. Now this one will be equal to 2. Now we have done. For this case, 299 is equal to this one. And if you want to prove it, you can see now 290 times 10 squared is equal to 10 times 10, which is equal to 2.90 times 100. Okay, then you'll get 290. Okay, these are the steps. Now the first step is to identify the first player, then the second player, then put the dot sign between the first player and the second player, then multiply by 10 power, then count the number of items from the dot sign. So it's how you can identify. Now this is how we write the numbers in standard notation. Now I'm going to give you the first example. Now I'll start with standard notation for positive numbers. Okay, standard notation. I'll start with the standard notation. Okay, for whole number. Okay, for numbers without your maybe let's say the whole number. Okay, whole numbers without your decimal, numbers without decimal sign. Okay, I'll start with them without decimal part. So I'll start with them. Okay, I hope you're going to enjoy this series, because it's simple if you follow the rules on what I'm going to show you now. Assume now you have given 492. Now write this one into standard notation. Now this is example number 1. Okay, write this one in standard notation. Now solution. Now 4, 9, or 2. This one is equal to. Now the first player is 4 and the second player is 9. Now I'll put a decimal sign between the first player and the second player. Okay, the first player and second player. Now I've put the dot sign between them. Okay, then times 10 power. Now count the number of items from the dot sign. Now it's 1, 2, 3. That is the answer. Okay, another question is, now assume you have this one. Okay, standard notation for numbers with without the the decimal sign. Okay, now another point is, now assume you have another question like this. Okay, example number 2. Now assume you have given 245. Now write this one into standard notation. Now solution 245. This one can be written as, now 2 is the first player and 4 is the second player. Okay, now it is 2.45. Okay, we put the dot sign between the first and second player. Now times 10 power. The number of items after the dot sign is there 2, so 1, 2. That is, okay. Now example number 3. Example number 3. I should have given this one. 1, 2, 3, 4, 5, 6. Now solution. Now this one will be equal to 1, 2, 3, 4, 5, 6. Now this one is equal to, the first player is 2 and the second player is 3. Now this one is 2.3, then times 10 power. The numbers after the dot sign here, show me to here, then it will be 1, 2, 3, 4, 5, 6, 7. Now this is power 7. Okay, that is. Then another example, example number 4. Okay, number 4. Now right there, this number is a notation 31 or 65. Okay, now solution. Now to send notation, this one can be written as 3 or 0, 6, 5, 6, 5, which is equal to. Now put this, the dot sign between the first player and the second player. For this case, the first player is 3 and the second player is 1. So put the dot sign between 3 and the 1, 0, 65. Then times 10 power. Okay, numbers or number of items after the dot sign here, 1, 2, 3, 4. So there are 4. Therefore, that is the form of standard notation. It's A times 10 A. So this one is the standard notation required. Now, the second part is going to show you how to write the standard notation for decimal numbers. Okay, standard notation for decimal number. Standard notation for decimal number. Now assume you have given this. Okay, assume you have be 0.029. Now you can be told now to write the standard notation for decimal number. Then how are you going to do this? It has the same procedures, but at least it's a little bit different, but I hope you can understand. Now the procedures are the same, but you need initially to identify the first player and the second player. Now the second player in decimal parts are always the numbers of starting from 1 and excluding 0. Okay, so the first player is 2. Okay, so always the first player and the second player, especially the first player should start with a number from 1. Okay, so the first player should be the number can start from 1, 2, etc. But second player can be any number. Okay, and second player can be any. Second player can also start from 0, 1, 2, etc. Okay, now for my question here, the first player is 2, it's not 0, because the condition is the first player should start to 1 and 2, etc. But the second player should not start with 0. Okay, the second player can start with 0. So here my first player is 2. Now write the first player is 2, then the second player is 9. Okay, then times 10 power. Now look carefully here. Okay, now look carefully. What is moved here? Now 2 has moved some steps to take the position of 0. So look here. Now it has taken the first position, 1, then 2. Okay, so it has moved 2 rounds until it attained this position. So we have moved the player to take this position. Okay, so it has moved step number 1, then step number 2, then it has moved 2 steps. but it has moved in a negative direction. Okay, the first player has moved to attain this pose, the first position, but in a negative direction, so it's -2. Now for this case, 0.029, this one is equal to 2.9 10 times 10 power -2. This is the solution. Now if you need to prove, you can see that 0.9, I mean 2.9 times 10 power -2, this one is equal to 10. It's equal to 10 power, I mean you're equal to 1 over 100, which is equal to 2.9 times, if you take 1 divided by 100, it's equal to 0, it's equal to 0.01, which is equal to this one. So if you need to prove it. Now, let me give you now example number 1 for writing the standard notation for negative numbers. Now, assume you have this one. Assume yours. That's example number 1. Example number 1. Now, assume you have 0.00045. Now, you have asked now to write this one into standard notation. Now, solution. Okay. Now, this one 0.0000. Sorry, there is triple zero, not 4. Okay. Now this one can be written as, now the first player is 4 and the second player is 5. Okay. Now this one will be equal to 4.5 10 times 10 power. Now this 4 has moved to the left hand side until it has taken the position of 0. So how many steps has it moved? Now you can see now step number 1, number 2, number 3, number 4. So it has moved 4 steps, but in opposite direction. That is the standard notation for 0.00045. Now example number 2, writing in standard notation for negative numbers. Okay, I mean for decimal numbers. Now assume you have given this. We assume you have 0.0401002. Now solution. Now this one will be equal to 0. Okay, yes, 0.04102. Now this one will be equal to, now the first player is 4 and the second player is 0. As I told you, the first player should always be a number starting from 1, but can be 1 up to 9. But the second player can be any number, either from 0 up to 9. Okay. Now from this, for this case, my second player is 0. Now it will be 0 or 1 or 2. Then times 10 power. Now you can see 4 has moved some steps to attain this position of 0. Now it has moved step number 1, step number 2. So it has moved 2 steps, but in opposite direction. This is how we do solve or write this standard notation for decimal numbers. Now assume you have this one, you have this challenge. You can be given a number with both decimal, but at the same time numbers without decimal. Now let's see example. Example number 3. Now assume you have given this. Assume you have this 245.924. Okay, this number we do consider it as a positive number. The other side, okay, the other side can consider it as a number without a decimal. On the other side, also can define the number with a decimal sign. But the only thing we need now is to follow the procedures I've already shown you. Okay, now 245.294 to standard notation. Now the first player is 2, okay, and the second player is 4, then 5. Okay, now what I've done here, I'll be moving 45 to the other side of the decimal side. Okay, now you copy to 44. Look here. What I've done here, I've taken this value, okay, 45, and then moved to the other side of decimal point. Now it has taken this position, okay, it has taken this position, as you can see here. So the decimal sign is before it. Okay, now we have just moved 45 to the other side. What I mean, I've taken the second player to the other side. Okay, now this can be written like that. Okay, now times 10 power. Yeah, as you can see here now, this one 5. It has moved to. You just count here. The numbers which have moved are 2. Now it's 4 and 5. Don't count the other numbers, as I told you previously, with numbers without a decimal sign. Okay, here I've just moved 2 numbers, 4 and 5. So they are 2 but positive. So I've taken 2 numbers and they moved it to the other side of the decimal sign. So if you have if you're given the questions of this kind, then you can do like this. You just take the numbers and they move to the right hand side, and on the exponent side, just count the numbers you have moved. Then this is the answer. Now another example. Example number 4. Now so assume you have given maybe 34.62. Now write to standard notation. Now solution. Now 34.62. This one will be equal to, now the first player is 3, the second player is 4. Okay, 462. Now I've just moved 4 to take this position. Okay, so I've just moved only one number. So this one will be equal to 10 power 1, because I've just moved only one number. Okay, now this is the answer of the standard notation for that number 34.16. Now another example, I think it's sample number, okay, this is for the example number 5. Now assume you have this one, 4 0 3 4 5.32. Now write this one in standard notation. Now solution. Okay, 40 or 345.32. Now this one will be equal to, now the first player is 4, then dot, the second player 0, then 0 3 4 5, means I'm just moving all these number to the other side of the dot sign. Now equal to, then it's equal to. Okay, yeah, you can see here I've taken this number, okay, and then I've plugged them here. Okay, that is exactly I've done. Okay, then okay, now I need to have a space here, put space, sorry. Okay, this one will be equal to, okay, let me write here, then 4.034532, then times 10 power. How many numbers have I moved? 0. Okay, just move the number from here up to here. So they are 4. Okay, 1 2 3 4. Then it is 10 power 4, but positive side. Okay, this is the answer. Now sometimes you can be now given numbers. Okay, you can be given numbers and told to find the exact number. For example, another example number 6. Now assume you have given 4.8 times 10 power 3. Now the question is, write the numbers, this number into decimal form. Write two decimal numerals. Write decimal numerals. Or you can be also told to find the value of this expression. Okay, decimal numerals. So it can be as not to find or to write into decimal numerals, or to find the solution of this one. Now solution. Okay, now 4.8 times 10 power 3. This one is equal to 4.8 then times 10 power 3 means it's with 10 times 10 times 10. Okay, so if you're not familiar with this, then please refer to my previous sessions of exponents. Okay, then this one will be equal to 4.8 then times 10 times 10 times 10 is equal to 1000. Okay, then when we multiply, you get 4,800. This is the answer. So in case of those who don't know how to multiply decimal, just think of this one. Maybe if I've given example 0.2 times 0.2, the only thing you can do here, just take the whole number of 2 times 2, which is equal to 4. Then count the number of decimal. Here you have first decimal and the second decimal. Then it means I have 2 decimals after the multiplication of these two numbers. Therefore, this is the first decimal, then the second decimal, then 0. Okay, or assume I've given you this one. Okay, maybe 0.003 times 0.1. Maybe, okay, let me say 0.2. Now you just take 3 times 2, 6, but you have the number of decimals. You have 1, 2, 3, 4. You have 4 decimal places. Okay, but this one you have 1, then 2, 3, 4. This one. So this is how we multiply the decimal sign, in case of those who don't know how to multiply decimal numbers. Now for this case, 400, I've just taken 400, 48. I've just removed, I've assumed I don't have the decimal sign. Then times this one times 1000, then I got this one. Then how many decimals do you have? It's 1. Therefore, so this one will cancel the 4.0. Okay, then it's how I got it to that one. Okay, now example number 6. Example number 7. Example number 7. Now assume you have given now this 3.5 times 10 power negative 4. Now write this one into decimal numerals, or find the value of this one. Now solution. Now 3.5 times 10 power negative 4. This one will be equal to 3.5 times this one means it's equal to 1 times 10 power 4. So if you have not understood this, please refer to my previous session of exponent, because the law of exponent, if you remember, says if it is a number, maybe here's the law of exponent. It says in case of any power p, this one also is equal to 1 power n, it becomes positive p. This is the law of exponent. So if you have not understood, please refer to my previous sessions. Okay, then this one will be equal to 3.5. So when you take 1 divided by this one will be equal to 1 divided by 10,000, which will be equal to 3.5 times 1 divided by 10,000 is equal to 0.0001. Now this one will be equal to 35 times 1, Okay, but it has a decimal. It has how many decimals? 1, 2, 3, 4, 5. Then 1, 2, 3, 4, 5 dot. So this is the answer. Now, another example, number 8. Now you can be now told to simplify. You can be given numbers into standard form, and you can be told now to simplify. Now, for example, if you have given this one 7, will be times 10 power 2. Okay, then times 8 times 10 power 4. Now you can be now told to simplify, then write now the answer into standard notation. Find the solution and write your answer into standard notation. Now solution, this one can be written as now copying the question, then 8 times 10 power 4. Okay, now this one will be equal to, now correct the like terms. For my case, it's 7 and 8 are like terms, and 10 power 2 and 10 power 4 are the same term. Now it's 7 times 8, okay, 10 times 10 squared, then times 10 power 4. Then this one will be equal to 7 times 8 is 56, and 10, this one will be equal to 2 plus 4 according to law of exponents. As well as if you have not understood this concept, please refer to my previous sessions. You'll be able to do that. Now this one will be equal to 56, then times 10 power 6. Now this one should be written into standard notation. Okay, it should be a decimal sign. Okay, now to standard notation 56, this one can be equal to 5.6, then times 10 power 1. Okay, because we have only 1. Okay, 1. Okay, then times 10 power 60. Okay, now this one will be equal to 5.6, then times 10 power 1 plus 6. Now this one will be equal to 5.6, then times 10 power 7. This is the answer. Okay, now example number 9. Example number 9. Find the solution and write your answer into standard notation. Now this is example number 9. Okay, now example number 9. Now show me what I have given. Now 7 times 10 power negative 2. Okay, and times 8 times 10 power negative 4. Okay, I show is positive 4. So let me write positive 4. Still positive 4. Okay, now solution. This one can be written as 10 power 10 power negative 2. Okay, then times 8 times 10 power 4. This one will be equal to. Okay, now this one is equal to 7 times 8, like the right times, then times 10 power negative 2 times 10 power 4. Okay, now this one will be equal to 7 times 8 is 56, then times 10 power negative 2 plus 4. Okay, according to law of exponent. Now this one will be equal to 56, then times 10 power negative 2 plus 4 is equal to positive 2. Now this one 56 right to standard form is equal to first pair is 5, the second pair is 6, and I moved just one item here. Then it is 10 power 1, then times 10 power 2. Now this one will be equal to 5.6, then times 10 power 1 plus 2. And this one will be equal to 5.6, then times 10 power 3. This is the answer. Okay, now should we have another example, number 10. I'm trying to give you a good number of examples because I've heard some lamentation from other students say, oh, logarithm is very complicated. One of the toughest topic is logarithm. No, today I need to prove you wrong. If you say logarithm is tough, now today I'm going to prove you wrong. Okay, just follow the rules. The logarithm is simple. Now assume now we have this one, 4 times 10 power 8 divided by 5 times 10 power 5. Now write the expression to simplify and they provide your answer into standard notation. Okay, now simplify an expression, then write your expression to standard notation. Now solution is 4 times 10 power 8 then over 5 times 10 squared. Now this one can be written as, now correct the right terms. Now for my case here, the right terms here are 4 and 5, then take 4 divided by 5, 10 times 10 power 8 divided by 10 power 5. Okay, then this one will be equal to 4 divided by 5. If you divide carefully, you get equal to 0.8. Okay, 10 times 10 power 8 minus 5 according to law of exponent. Okay, so exponent, if you have forgotten, a power p divided by a power n. This one is equal to a p minus n, in case you have forgotten. Okay, now look here, this one will be equal to 0.8, then times 10 power 8 minus 5 is 3. Okay, but should write this one to standard notation. Now should move 8 to the other side. So when you move, it will be 8.0. Okay, then times 10 dot, because there's moved just one step but in opposite direction, then this one is -1, then times 10 power 3. Okay, then this one will be equal to 8.0 times 10 power -1 plus 3. Then this one will be equal to 8.0 times 10 power -1 plus 3 is +2. This is the answer. Now the final example. In this part of our notation is this one, the example number 11. Okay, now assume now you have this question. Now you have 48 then times 10 power -5 over 20 times 10 squared. Now solution. Now find the solution and write your answer into standard notation. Then 48 times 10 power 5 over 20 times 10 squared. Okay, now this one will be equal to, write the common terms. Now it's 48 over 20, then times 10 power 5 over 10 power 2. Okay, now this one can be equal to 48 divided by 20. Okay, I don't know how much you're going to get, but if you divide it carefully, you can get this one will be equal to 2. 42.4. Okay, then times 10 power 5, okay, minus 2. Okay, power 2. Now this one will be equal to 245.4 times 10 power 3. Okay, now this one, write to this number, write to standard notation, will be equal to 2 with 4 2. The first pair is 2, the second pair is 4. Then I'm going to move 42 to the other side of 4. Now this will be equal to 10 power. How many numbers have I moved to the other side? They are 1 2 1 2. They are 4 and 2, so they are 2. Okay, now this is the answer of the question I've asked you to write it to standard notation. Now for today, I like to end there. I like to invite you to the next session. For today, thank you.